Building the parser part 1. That is what we're going to be talking about today. I know we went over the parser before, but considering all of the crazy things that I've done to my language, I think that it's safe to say that we should probably start over. And from this point out, there shouldn't be any situations where I'm having to rehash old videos that I did a while ago. So this one's going to be pretty fun, so let's get right into it. What is up, guys? DevCode here, back with another video. So today we're going to be working on our parser, and like I said, there's been a ton of things that have changed. So, and as you can see, there's a lot of functions here. I'm actually going to show you guys how to build a parser in C++, in the actual language that I'm building the language in. Which is really nice. Last time I showed you it was written in the language itself. So today I'm not going to be showing you guys any code inside the parser. What we're really going to be doing is setting up our compiler so that we can use the parser. So the first thing that we're going to need to do is we're going to need to go back up to here. So I made quite a few changes with the compiler. As you can see, I've changed the structure. I have front end and back end folders with a bunch of other stuff in there. So first we're going to talk about options. So I've added a ton more options because I've made so many changes. It's required me to add quite a few more options. So we're going to have to first create our options object. So this is what the compiler is going to use for its entire life cycle. And what we're going to need to have is, we're of course going to need to have our aggressive errors. So this is a Boolean flag that basically states, I just want to print everything. I want to bitch about every possible error that has been found. And this is kind of helpful when maybe the compiler or the error management system isn't giving you what you need, and maybe you just want to see all the errors that happen. But considering that my compiler likes to complain a lot, this is set to false by default. After that, we have compile, so you can set this to true if you don't want to generate code. So you just want to compile everything to make sure that it works properly. After that, we have our out file. You guys know what that is. It's pretty self-explanatory. Next, we have our application version. So this is data that's actually going to be passed to our virtual machine. So once our code gets compiled, this information is going to be passed to the virtual machine, and you can actually access this data at runtime. So if we go here, I'm actually going to show you this really quick. So I have a couple things in here. This is basically the kernel. This is like once the programming language starts up, these are all the low-level classes that do things to set up the programming language. And if we scroll down, we can actually see here in the actual object args, and again, this is another way, as you guys saw in my last video, this is another reason why we need to have this as the starter function, because we don't just get the arguments that are passed by the user from the console. We actually get a lot more data than that. So we actually get the application name, we get the version, the platform, so whether it's Windows or Linux that the programming language is executing on, or no, actually it's OS. So OS is where what the operating system that the language is running on. Platform is the number or the ID of the platform. So my runtime system has multiple different platform IDs. As I progress and add on new features to the programming language, the platform ID will increase. Kind of like how Java has like Java versions. That's pretty much what that is. But yeah, so we need that in our options so we can pass that back to our program. After that, we have warnings. So I think this was here before. We want to be able to disable or enable warnings. Pretty self-explanatory. Next, we have optimized code. So this is a feature, or this is a flag that you don't want to have this here. The only reason this is here is because my optimizer before was super sketchy, and it's probably going to be super sketchy again once I start writing it. So as I'm building my optimizer and as I'm writing my compiler, there might be situations where I want to set this to false, maybe because the optimizer is just broken or something. Next, we have debug, which isn't currently being used, but this is basically setting the code to debug. I think that this is used for the actual programming language. So what I think this is this is a flag to allow for your programming language to be debuggable, kind of like how you have GDB for C++ debuggers, or to debug your C++ code. I don't have a debugger written for Sharp yet, so this is just kind of like this doesn't really do anything, but yeah, that's what that is. Next, we have strip debugging info. What that does is every time our code gets compiled, so here's some old files that was generated by my compiler. Every time our code is generated, it has a ton of metadata, right? So it has, the files that's been created. It has here all the string literals that are in the language or in our program. And then, of course, you have like your metadata. So there's nothing in here that explains it, but basically what metadata is the compiler is going to inject all of the source files that the code was running on. So that way, when you get errors, you can kind of see like, all right, here's where the exception happened at. But yeah, that's what that is. Next, we're going to need warnings. Warnings is errors. This is another thing that I think is new, where basically if we want to force every warning that the compiler gives us, it can be translated into an error. After that, we have magic. This is an Easter egg. This actually isn't in the, like when you type help in the compiler, this actually doesn't pop up. Basically what this does, and you probably don't need this if you're building a language, I just thought this was cool to add. All it does is it allows for the compiler to automatically resolve everything in the language. So it's basically just a flag where the compiler just knows what everything is, and you don't have to type import statements. So you don't need like import std, import std.io. Like you don't need to do any of this anymore. You can just like, it just knows what everything is. Okay, debug mode. This is very important. You're probably going to want to have this flag. This is yet another Easter egg. You're probably going to want to have this in your programming language as well. And basically what this does is this allows me to see debugging information in the compiler. So I'm going to compile this code here, and you can see it says ready to compile because my compiler isn't done yet. But if I go up here and I type -debug, what that's going to do is that's going to set this debug option flag to true, and you'll be able to see a little bit more information. So you can see it tells you what files it's tokenizing, what files it's parsing, and then it tells you performing syntax analysis. And it'll give you a little bit more information too. I don't remember exactly what circumstances where it gives you more data, but yeah, that's what that is. That's very useful for when you want to see what the compiler is actually doing. Maybe you want to figure out like where it's crashing or whatever, but yeah, that's really nice. ASM dump, this is not being used right now because my optimizer isn't built yet, but what this is this is what this file is. So it's just a flag to say I want to create a object dump file. That's what OJD stands for. And I want to basically dump out what the compiler generated so I can actually like see functions, and I can see like here's the function address, here's the file that it was initialized or where it was created at, more metadata like the line and the column, and more stuff. And then you can actually see like some really cool, like you can really get down and dirty and like look at where everything is. That's something I'd recommend if you're going to build like if you're going to build an interpreted language. You're probably going to want to have that as a feature or a flag in your compiler. Next, we have error limit. This one is pretty straightforward. It's just so that our compiler doesn't create thousands of errors. So I set my error limit to 1,000. The user can increase it, but I set a limit to about 100,000, so the user can't have more than 100,000 errors, because why the hell would you want to have more? And here's target. So this is important. So for every version of my compiler, it's going to target certain versions of the programming language. So a while ago, I had like base, which is like one version of the Sharp programming language, and then this is the next version of it. So this was like when I overhauled the entire runtime system. That's when I started back here. And that's also what this is. So like if we go to our runtime, that's what this platform is right here. So this platform is just the number of what platform you're running on. Next, we have libraries. What that is so like you can see here. So I have -l lib support blah blah blah. What that allows you to do is instead of constantly having to type in every single individual file that you want to compile, you can just say this is a library, and you can pass it the folder name, and it will literally just get every single file inside of the folder name. So that's what that is. That's really cool. Next, we have ASM dump switches. This is pretty advanced. What this basically does is, so I'm thinking about coming up with a different syntax and language for programming the actual virtual machine that will basically abstract me even further so that I don't have to worry about what each instruction does. So I'm not really gonna, we'll revisit this a little bit later, but just know that this is for the optimizer and for generating code. Next, we have warning switches. So if you remember before, I had a flag where I could say I want warnings set to enabled, and I also have set warnings as errors. So I also now have a feature where you can specifically disable certain warnings. So like you can just disable every single warning, like general warnings, or you can disable warnings related to access. So like, I don't know, let's say you were accessing some field and you were doing some weird stuff, so on and so forth. After that, you're going to want to create a warning map and an ASM dump map. So that is the basic setup for setting up our options for our compiler. Once you do that, immediately after that, you're going to need to start setting up your actual code so you can compile everything. So you can see I added quite a few more options. So let's go through that. So here's how I decided to write the logic for enabling and disabling certain warnings. So basically what I have is, if we go back here, you can see that each of these warning switches have a number tied to them. And what that number is that's basically the index of the actual, like where it is in the warning map. So, and I actually put comments here to make it a little easier for you to understand. So we have, of course, general warnings, W access, mbig, all that stuff. And you want to set them all to true initially because the user hasn't disabled any of them yet. So now after that, you have your ASM dump map. Everything is going to be set to false originally. Basically what this means is I'm going to output the data in its rawest form. For when I create my dump files, I'm not going to do any translation or anything like that. Again, we'll get into that later. Next, what you're going to need to do is you're going to need to create an actual object for your options. So C options, which represents compiler options. You're going to want to put that in your main file, and you're going to want to put that as an extern. So you're going to put that as an external variable. That way your compiler can access it. After that, you want to create some helper methods. So I created a couple helper methods here. So I created an ends with. So you basically pass in a string, and then you pass in another string. So you want to say if the value of this string ends with this ending, return true, and that's pretty much all it's doing. You can kind of see what the code's doing there. It's pretty straightforward. After that, you want to create a structure called stat, and this allows you to basically get the full file list. So if you remember before, that flag -l for libraries, this is the code that's basically going to get every single file from your folder. So you're going to have that, and I don't really know what the hell most of this is doing, so I can't really explain it to you. I literally just copied and pasted this from a Stack Overflow question. So if you want, just copy it, right? Like if you're building your programming language, just copy this. I'm not even going to try to attempt to explain what's going on here. What's important though is, I have this code that I added. I don't think this was in the actual Stack Overflow. And basically what that is you want to see if, a file that's in the directory. So once you get all of the elements in the directory and you're like looping through them, you want to see if there's a directory inside of that directory, and if there is, you want to do a recursive call back into the function. And that's pretty much it. Next, we want to see if every file ends in our language. So we want to say if it's a sharp file. In our example, basically for my library, I'm processing 0.2.805 because this is my new standard library that I'm writing. So I want to make sure that all the files end in sharp. And if it does, then we want to add that file. Otherwise, if we can't find a directory, then we'll say warning, cannot find support library files and path, whatever the path was. Do you have them installed? Okay, that's an incorrect message. I'm gonna change this live. So cannot find library files and path, whatever. Have you provided the appropriate name for the directory? Yeah, so that's what that does. So basically, if we can't find a directory that the user wants to set as a library path, then we just say, we couldn't find it. All right, so now let's talk about now you need so for every programming language you're going to want to have like a help function, which basically just allows the user to see like what can they do with this program. Mine is really big. I added a ton of stuff, so let's just go through it. So for my options, I have -v, which prints the compiler version and exits the compiler. That's all it does. Show version, which, I mean, you can read it here, but I'm just going to go through it. This shows the version, but it continues along. It doesn't stop it. O sets the object file or the output object file. I'm not going to open it, but you have your object file, which is a binary, and then you have your object dump file. So those are the two files that get generated. You're going to need to have your compile, so you can compile only. And all these basically are, all these options, they're just attachments to the flags that we created here. So that's pretty much all it is. And yeah, you guys can read the rest. I'm not gonna like go through all of them because I have descriptions here that explains it. But the ones that I really want to focus on are HW and ASMD. So we basically with these want to print out additional help messages so that the user can see what they can do with this. And I suggest that you do this whenever you have a programming language that's really complicated and you have so many things that you can do with it. You want to break up your help message. You don't want to have like a 50-line help message with all these different things because the user's not really going to be able to sort through that and figure out exactly what they want to do. So what I decided to do was break it out into a separate help message for both dumping the assembly files and for help warning options. So let's look at help warning option. Of course, we do our vanilla normal printing right here. We just print the normal stuff that we print up here. And then after that, we have, of course, our disable all warnings. So that's going to set this flag to false. And then after that, we can disable individual warnings. So what this is going to do is that's going to set one of these flags to false. And yeah, that's pretty much it for help warning. And of course, you can read it. This is pretty self-explanatory. And you can see what each individual warning flag does. So once we get deeper into our compiler, we'll see how to actually send these warnings with these specific flags. So that way, if the user has this specific flag disabled, then it won't get printed. So we'll go over that a little bit later. Next, we want to help or print out the message for help ASM. What that is going to do is, of course, we print our regular stuff. So I put a little bit more information here. So I say, please note the default format will be printed as is with no debugging information, syntax reformatting, or address information. So the reasoning for this is whenever I print out my object dump files, I print out a ton of information, but sometimes you may not want certain information to be in there or you just don't really care. So maybe you want to bring down the size of the object files being dumped. So that's kind of why I did that. Basically, you can just dump out the raw code, um, or you could demangle it. And basically what this does is this is going to do this. So let me see if I can find an example here. So demangle is this, right? So you say call 558. Well, what the fuck does that mean? We basically want to call this function. So that's what demangling is going to do. It's going to allow us to do that. So that's you want to make sure you add that flag -s or ASMDS. You basically want to reformat the code. So you're basically going to convert this garbage into something more readable. I haven't implemented that code yet, but we'll get into that a little bit later. After that, you want to set your debug information. More on that later, and you want to display the help message. Okay, so next you want to have a function for erroring out. So if you have an error, you just want to say bootstrap error, or I don't know why I did that, sharp C error. So you basically would just want to say, hey, the compiler broke because of this reason. Here's print version. So if you remember, I have a show version up here, and what that does is that just prints the version of the compiler, but it does not call exit. So it doesn't call the exit function and completely close out the program. Next, after that, we have to lower. This is just a helper function that basically converts a string to the lower values, and then it returns a new string. Pretty self-explanatory. So you guys can copy that if you want. Next, we have all integers. This is important for something that we're doing a little bit lower in the code, so I'll show you that in a little bit. After that, we have starts with. This is also important for something lower in the code. We basically just want to check to see if a string starts with a certain prefix. So you basically just check to see if the prefix is greater than the string, then obviously it doesn't start with it because the prefix is bigger than the original string. And then we just check to see if it's true. That's it. Okay, so next we want to call our bootstrap. So if our arg is less than 2, then we want to call the help function. All right, so now what we're going to do is we want to call initialize errors. We've already seen this code. Basically, that just initializes or creates a map of all of the errors that we have predefined in our code. If you guys want to check out the errors that I have, you can just check out the error manager file, which is located in the front end and error manager, and you can check on my GitHub repo if you want to like look at that. It's literally at the top of the file. But I already, like I said, went over this in a previous video, so I'm not going to talk about it now. So you want to set up your files and you want to set up your ASM dump prefix. So that ASM dump thing allows you to do some pretty cool stuff. So typically when it comes to like having errors or having flags where you can say here's an option, here's another option, they're pretty much just simple string compares, like does this option equal this value or does it equal this value, so on and so forth. But ASM dump is a little bit more complicated. We first check to see if it starts with ASMD, whoops, and that's why we have this starts with function here. And then we just pass the characters right after this colon here. So you can say ASM dump IS, ASM DSI, or ISD, or whatever. Doesn't matter the order. And you can basically just tack on like flags here. So yeah, that's what that is. Let's see. Okay. So now we want to process all of our flags. So this is really easy. You just say you basically pair the flag with the option name. So that's it. So we want to set our errors here. Then we want to set whether or not we want to compile only. We set our output file. So we basically want to check for argc and we want to add I+1. And if it's greater than or equal to the total args that we have, then we want to say the output file was required. Otherwise, we just add it here. Library file, we want to just add the string, and we'll process our libraries later, but we just want to add it to this list for all of our libraries. And again, we're expecting something after this, so we do the same code we did up here and say we expected a library afterwards. After that, we have our V. So remember, V prints the version and then exits. So that's what that's doing. So it's exiting with code 0 and printing the version. After that, we have optimize. This is whether or not we want to optimize our code. We have our help. So we, of course, are going to print out our help function here. And we also have question marks. So these are two ways to print out the help message. And then, of course, you want to exit. So you want to shut down your code or your program. You don't want to continue. Same thing with help warning. You want to print out the help warning and shut it down. And as well as ASMD, you want to print the help ASM and shut down the program. After that, you have your release. So this is more for like debugging later on. These don't really mean anything right now. With the exception of strip and optimize, debug doesn't really mean anything because there's no debugger. So, but setting your program or your application to a release mode basically means I want to strip all debugging info. So that means when we get an exception, we can't see where it happened in the actual code. We'll just know it happened at this function. Like I said, debug doesn't do anything, and then optimize just optimizes the code. So if you set your code to release, then that's what that does. Eventually, I'm probably going to remove optimize, and just once my optimizer is fully stable, I'm going to always optimize all the time and just not have the user have to care. But yeah, that's what I'm doing for now. After that, we have strip, which sets the code to debuggable false. And we also want to strip the file. So this is important, right? So even though I don't have a debugger, this is a very important distinction because you can see here, even for release mode, I set debug to false and strip to true. Basically mean that if we have a release function or if we have a release program, we can't debug a release application. So we want to set the application to not be debuggable and then strip the debug information and optimize it. That way, if you do all of that, you can't really figure out what's going on because the optimizer is going to obscure a lot of things that are happening. After that, of course, we have our magic mode. We already talked about that. Debug mode, we talked about that. And I'm going to do this too, but I suggest once you actually get your compiler up and running to remove this. Like, you shouldn't have this here. This is only for like development purposes. Show version, again, so you see we print the version and we don't do anything. We don't shut down the program after that. After that, we have target. So this just basically checks for a target version of the language that we're supporting. So we can either support base or alpha. Base is so damn old, I don't even know why I have it here, but I guess for completeness, I added base. But yeah, you can say here's the name or the number of the target version that I want to run the virtual machine on. So just like Java, you can pick, I want to run on version 7 of the virtual machine. This is pretty much what this does. And it just basically takes a string and converts it to a number and sets the target value because the target value is an actual integer. After that, we have warning, setting our warnings to false. So this disables all warnings as described above. And then we have all of our warning flags. So this is where you can actually see it, right? So if you remember, our warning switches have indexes attached to them, and they're also attached to the warning map here. So what we do is we just say this warning at this index in the warning map, set it to false. So when we go to print this warning in our compiler, we're going to check to see if warning map at wmbig index is set to true. If it is, print the warning. Otherwise, don't print the warning. After that, we have v. So that's for your file version. Or no, that's for your actual application version. So we already talked about that. Next, we have w error. That sets all warnings to true, so that sets the W errors to true and warnings to true. Pretty straightforward. Next, we have error limit. So what this does is this gets the limit from the actual arg. Oh, I actually just found a bug here. So here, I'm going to actually do this live. So I actually wasn't checking for I+1. So if I do this, otherwise delete, there we go. Okay, so we basically just get the error limit from the next argument. We check to see if it's all integers, because if it's not, then what the hell are you doing? And then we convert that string to an integer and set the value of the error limit. And then I do a check. I just want to tell the user you cannot do that. And then I also print out, you also want to print out what the user did, like how many errors that they have. And if it's less than 0, you can't have negative errors, which doesn't make any sense. In fact, I'm going to change this. I'm going to say less than 10 errors. And otherwise, if it's not all integers, like I said, it doesn't make any sense. Next, we have our ASMD stuff. So that's for our ASM dump flag. And finally, we have our ASM dump prefix. So what I'm checking is, does it start with this ASMD? So if you remember above, I was talking about how it's dynamic. So you can say ASMD this, and you can say IS, DSI, ISD, whatever. So that's what this is. So we're checking to see if the flag or the next argument that we're getting passed by the user starts with the ASMD prefix. Then what we do is we get that value and we do some math here. So we check to see if the option size is greater than 6 and less than 9. So what that means is it's very important. So let's scroll up to the top. So you want to check to see if it's greater than 6. So that means we have 1, 2, 3, 4, 5, 6 characters. So if you just typed ASMD, that means the size is 6 characters. And if it's not greater than that, then there's no options. So that doesn't make any sense. So it has to be greater than 6, but less than 9, right? Because if you do 6 plus 3, that equals 9. So if you do 6, 7, 8, 9, that means we have a maximum of 3 additional flags. So we're expecting 1, 2, 3. So if it's in between that, then we're good. Otherwise, we error out. We basically just do a for loop over the char, and we start at config. So what we do is we get a substring, we get a substring of 6, so we start at 6 and we get everything after 6. And if you remember, we know that we're guaranteed for it to be greater than 6, which means we have something after this ASMD colon, and less than 9, so there should be other stuff there. And if it's any one of these options, then we want to say asm.map, and we want to set the option here for that at this index. So they each have their own indexes, and that's how we set those flags. And it's pretty straightforward. Otherwise, if it's not one of these, then we just error out and we say, I don't know what this is. We finally have a dash. So if it's a dash, then, or if the first character is a dash, that must mean that it's an invalid option. So we just say invalid option, we don't know what this is. Otherwise, if it doesn't start with a dash, then it has to be a file. So we want to make sure of that, and we want to say, add the file. Now, here's an important distinction. So typically what happens is, or the typical flow of a compiler or a program is you have your options and then you have your files. But what if the user wanted to put an option after they put the files? Well, you want the user to be able to do that. You don't want them to have to just only be restricted of putting the flags before. So you want to say, does the string start with a dash? If it does, go back up to args, which means we just process all of this stuff that we just went over. Otherwise, it must be a file because it doesn't start with a dash. And then you just do that for the end of argc, and you just, of course, you got to increment the I, and you want to post increment it so that you can get the current index, get the string, and then add the file. So once we do that, we have, so as you can see here, my programming language supports both Windows and Linux operating systems. So I have two separate different storage locations for Sharp. So for Windows, I have C, program files, Sharp, include. And what that is this is where the standard library is going to live. So whenever you install Sharp, the code that is in the standard library is going to be injected into this folder here. So that's going to be injected into this folder, and if it's a POSIX, then it's going to be injected into this folder. So it's going to be user include sharp. But yeah, so that's why I have this define here. And let's see, can I actually go to this define? Okay, so here's another important thing. So here's basically how I figure out whether or not I'm operating on a Windows or a Linux system. So basically what I do is I compile this using CLion, and I also have a Linux server that I compile this code on as well. So once the code gets compiled, at compile time, it knows which operating system it's operating on because of the certain flags. So if we have any of these flags, it must be a Windows, otherwise it's a POSIX system. So that's basically how I figured it out. So if you want to add those, this is a great way how you figure out whether or not you have a Windows or Linux system. And I basically use these flags everywhere, so that's really cool. All right, let's go back. All right, so next you want to add your library files. So if you remember, we had our includes. Is that what that is? No, that's not. I'm incorrect. Okay, so we have our path. So we get our path, and this is basically our install path. We try to get all the files in our install path for our libraries, where our standard library is installed at. And if there's no files in there, no harm, no foul. Who cares? We'll just, like, if we can't find the folder, of course we'll tell them that, but if there's nothing in there, there's nothing in there. So we do that, and we do that for all of our libraries. So we first try to get everything in the standard library, and then we do a for loop over all of our libraries. So if the user did a -L, don't remember where it was, but if the user typed option -L, then we'll add all the files from those folders that they, put in their options. After that, we want to set our includes. I don't know what the hell that does. What is this? Oh, okay. So I'm gonna actually leave this in. So what this does is this is basically just adding all the files that we found from our standard library. And we still have no files. We probably would want to say help. They maybe did something wrong here, right? If we literally have nothing to process, like so we want to tell the user like, hey, you did something wrong, or we just want to basically print the help thing. After that, we want to look for files, and if files is greater than 1, we do that. But yeah, so we basically go through all of the files that the user said they wanted to process. We first check to see if the file exists. If it doesn't exist, we tell them. This is why we want to have our error function here. If we have like a critical error, then we want to basically close the entire program, because if the user wants to compile a file and it doesn't exist, well, that's obviously an issue. So there's that. And if it doesn't end with a sharp file, well, then that's also an issue. And if you remember above, as we're processing our library files and we're processing all the library files that the user provided, so our standard library and then the files that the user provided, it's only going to add files that's a sharp file, so we don't have to worry about those being non-sharp files. We only care about the stuff that the user had said that they wanted to process and whether or not they're sharp files. If they're not, then we basically error out. All right, so this video is pretty long. The next thing that we're going to talk about is compile, but that's going to be the next video. So this is part 1 of setting up your parser. You obviously needed to do all of this before you actually set it up. So next episode, we're going to talk about how to actually start the compilation process. So you already know how to build a tokenizer because I've made videos about that previously. So we're going to put together everything that I showed you guys before, and we're going to go from there. So that's it, guys. If you guys would love to help out the channel, definitely check out the GitHub repository. This is where Sharp is actually being developed. If you want to be up to date with what's going on, definitely check out the remastered branch. I update this almost on a daily, weekly, or even monthly basis. If you would also like to get more information about what exactly I'm looking to do, check out the roadmap file. This is going to outline everything that I'm looking to add into the language, and as well as things that I've already completed. So definitely check that out, and if you want an even more detailed description of what I've been up to, check out the change list file and you can see all of the updates I've made thus far. So hope you guys enjoyed the video. Definitely like and comment and subscribe if you guys like what you saw and you want to see more. Until next time, I'll see you guys later.